Good morning, everyone. I'm Fong, and today I would like to give you a presentation about the literature review of my presentation. And my presentation will be briefly divided into several sections. First of all, I will tell you the research title of my research topic, and then I will tell you the reasons why we have chosen this topic and some background information for our topic. And then I'll tell you some the findings that we have found from the literature reviews, and also tell you some niche and the aims of our research topic. And the title of our research topic is Numerical Solutions to Resolve Bottleneck Problems in Hong Kong. And we are wondering how to reduce the traffic bottleneck problems in Hong Kong by numerical mathematics. And we have assumed that the optimal density of vehicles and velocity could reduce the problem. And the reasons why we have chosen this topic is that the increase in traffic flow will lead to congestion. And when there is a congestion, then there will be some time delays, and as a result, and also there will be the decrease of flow rate. And with these factors, and there will be some, because there will be delays, and there will result in some high fuel costs. And this high fuel costs will lead to some economic problems in Hong Kong and also all over the world. And also the problem with the fuel will also result in some negative environmental effects. And because of all these factors, and some professionals from all different disciplines have been paying more and more attention to this vehicle travel problem, and they are trying to do something to improve the efficiency of the current highway systems. And there are different types of traffic flow. They are free flow, synchronized flow, and wide moving jam. And in a free flow, if we increase the density of the free flow, then it will result in synchronized flow. And in a synchronized flow, if we increase the density, then it will result in wide moving jam. And the most obvious and there are several factors that may cause a wide moving jam. And the most obvious factor is that the vehicle parameters, which includes the size and also the velocity of that particular vehicles. And also, if there is a velocity drops below the critical value of the free flow, will also result in a wide moving jam. And some studies has also pointed out that the individual driving behavior of the drivers and also some factors from psychologists will also result in wide moving jam. And all these factors will lead to the problem of congestion. And congestions always appear in some bottleneck areas of highways. And there are mainly 4 types of situations where bottlenecks will appear. Usually, a bottleneck appears somewhere near a tunnel or a roundabout, or after an accident, or if there is a decrease in numbers of lines. And take an example in Hong Kong, those cars before the cars enter the Cross Harbour Tunnel, the lines will change from 6 lines into 2 lines, and this is an example of decrease in lines. And also, when the car travels on ramps or off ramps, that is when cars are running on a slope, then this will cause the problem of bottleneck. And as we have read about 5 research articles, and we found that there are different approaches for the solving bottleneck problems. And the first one is called BBT model. And from one of the article, we found that it has introduced 2 real-life bottleneck setups. That is the change of lines from 3 lines into 2 lines, and also a on-ramps and off-ramps setup. And in their research, they have considered the vehicle densities. And they found that the moderate density of And at the situation of a moderate density, if we increase the density of the vehicles, then it will increase the width of the synchronized flow. And on the other hand, if there is a situation of large density, that is the wide moving jam, then even if we further increase the density of the vehicles, and the width of the wide moving jam will not be changed. And so they have concluded that the change of the interface will not affect the width of the wide moving jam. And the other article has also used this BVT approach to study the bottleneck problems, but only the vehicle velocities was considered. And the other approach is called LWR model. And there are two articles that use this approach for their research. And one of them used the wave and used this model to model the wave propagation properties. And they have found the relationships between the stop and go wave and also the bottleneck effects. And the other one, they have set a 1T road and also an NT road setups for junctions. And they have found that they can come up with the similar results. And with these results from the NT road, they can model the traffic and traffic problems and to model a traffic on the roundabout. And the last approach is use some general and numerical methods. And in that article, they have introduced some congested traffic patterns, and they have found that if the driver behavior and also the vehicle parameters can decrease, then this can decrease the congestion pattern properties also. And having read all these 5 articles and concerning about our research topic, we think that there are gaps between the papers and that we would like to fill in. And as we are going to study the bottleneck problems in Hong Kong, and so we should consider all kinds of vehicles that run on highways. But however, as the first article that I have mentioned, the study did not consider the case of trucks. And so, which we think that trucks trucks and buses are long. Can be considered as long vehicles, and which should be very important in the case of Hong Kong. And combining all the 5 articles, and we think that none of them have studied the bottleneck problems by combining all the factors of vehicle density and also vehicle velocity. So in our research, we will consider all the factors that may cause congestion and bottlenecks to resolve the bottleneck problems in Hong Kong. And so this is the end of my presentation. Thank you.